So get this. Imagine taking the raw power of a supercomputer, all of its learning ability, and somehow cramming it onto a microchip that's like the size of your fingernail. It sounds like straight-up science fiction, right? Well, it's actually one of the biggest puzzles in tech right now, and the solution is, well, it's incredibly clever.
I mean, think about it for a second. Your smartwatch, your smart speaker, they're handy, sure. But do they really get you? Do they adapt to your unique habits? Not really. Most of the time, they're just following a script and sending all your data up to the cloud to do the heavy thinking. They're smart, yeah, but they're not actually learning from you. So the vision, the big dream, is for these little gadgets to start learning on their own. We're talking about using your data right there on the device itself. Imagine a fitness tracker that learns your body's unique signals, or a smart assistant that adapts to your way of talking. And it does all this without ever shipping your private data off to some server. That's the goal, real personalization with total privacy. But, of course, there's a catch. There's this huge wall standing in the way of that future. It's a memory problem, and it's so massive that for a long time, people thought it was completely impossible to solve. So let's dig into why your smartwatch can't just learn things the same way a giant data center does.
Okay, this analogy really nails it. Training an AI model takes a ton of working memory. It's kind of like needing an entire library's worth of books open all at once to find the right information. Cloud servers? They have gigabytes of memory. They are the library. But your tiny little smartwatch, it's working with kilobytes. That's like trying to understand the whole library by looking at a single page of notes. It's just not going to happen.
And here are the cold, hard numbers. You've got your standard AI frameworks, PyTorch and TensorFlow. They need hundreds of megabytes of memory just to get going. Now look all the way to the right. See that tiny, tiny little sliver? That's what these researchers pulled off, a system that runs on just kilobytes. The difference is just wild.
So here's the number that really matters. To take a standard AI framework and get it to fit on a tiny little chip, you have to shrink its memory needs by a factor of 2,300. That's not just a small tweak. That is a gigantic, fundamental leap forward.
And hey, don't just take my word for it. The researchers themselves said it in their paper. They called this gap so huge that it makes on-device training, and I quote, impossible with the tools we used to have. So, how in the world did they solve an impossible problem?
Well, their solution was this awesome two-part breakthrough. First, they went after the AI's brain, the algorithms themselves, the code that tells it how to learn. They didn't just try to make the old method smaller. They came up with totally new, much smarter ways of doing things.
All right, so the first big idea has a kind of nerdy name, Quantization-Aware scaling. Look, all quantization means is saving space by using simpler numbers. Think of it like using a blurry, low-res photo instead of a super sharp one. It saves space, but it's hard to learn from. This technique, QAS, is like giving the AI a special pair of glasses that helps it see and learn from that blurry data perfectly, without making mistakes.
And the proof is right here in the data. That top line, that's a big, powerful cloud model getting about 73% accuracy. The second line is what happens when you just shrink it down. The accuracy tanks. But look at that bottom line. When they add their special technique, the tiny model's accuracy shoots right back up, basically matching the giant one. So, problem number one, solved.
Their second algorithm is called sparse update, and it's just plain brilliant. See, normally when an AI learns something new, it's like it has to reread the entire library just to add one new fact. It's super inefficient. This new way is different. It intelligently finds just the few key parts of the model that need to change and updates only those. It is literally the definition of studying smarter, not harder, and it saves a ton of memory.
Okay, so you've got these incredible new algorithms. That's amazing. But that's only half the battle, right? You can't just drop these into any old software. You need a system, an engine, that's built from the ground up to run them efficiently.
And that's where the Tiny Training Engine, or TTE, comes in. It's this super efficient system that does three really key things. First, it does a bunch of the hard work ahead of time, before the code even lands on your device. Second, it's like a surgeon, carefully trimming away any part of the learning process that isn't absolutely essential. And third, it cleverly shuffles calculations around so it can reuse memory on the fly. So here's a good way to think about it.
If frameworks like PyTorch and TensorFlow are like these general-purpose factory machines that can build anything, the tiny training engine is like a Formula One race car. It's not built to do everything. It's custom-built and perfectly tuned to do one single thing, on-device training with absolutely breathtaking speed and efficiency.
So we've got the smart algorithms. We've got the custom-built F1 engine. The big question is, does this whole thing actually work? Well, this is where it gets really good. This is the payoff.
And the numbers, they're just mind-blowing. They actually hit that 2300x memory reduction. The whole training process is over 20 times faster. The accuracy, it doesn't just get close to cloud training. In some cases, it actually beats it. And the whole shebang fits inside a 256 kilobyte memory budget. Incredible.
And just look at this speed difference. A traditional update would take over 8 seconds to process one thing. Their new system does it in less than half a second. That's the difference between something being a cool idea on paper and a technology you can actually use in the real world.
But this might be the most jaw-dropping result of all. On a standard industry test, their little on-device system was actually more accurate than the exact same model trained in the cloud. Let that sink in for a second. The tiny, super efficient system didn't just keep up with the big powerhouse, it beat it.
So this is way more than just a cool research project. This breakthrough completely changes the game for all the devices that you and I use every single day.
What this unlocks is the future we've been promised for years. We're talking true personalization and real privacy. Your sensitive health data gets analyzed right on your watch, never leaving it. Your smart assistant learns your voice and your quirks without needing an internet connection. Our devices can finally start to learn throughout their lives, constantly adapting to become uniquely, perfectly yours.
This research doesn't just shrink AI, it unleashes it. It lets AI live right alongside us, in our pockets and on our wrists, privately and personally. And that leaves us with a really fun question to chew on. Now that our devices can finally learn, what's the first thing you're going to teach them?